So I'm going to draw how a plane mirror reflects images, like let's say you or I. Okay, so we're going to start with a 2-inch tall person. Now the purpose of this demonstration is to look and see how does a reflection, or what would our reflection look like in a mirror that is half the size that we are. So if this was a person, okay, then what we want to do is we want to look at what would this reflection look like, so this 2-inch line, what would it look like in, let's say, a 1-inch mirror? Well, the first thing we'll do is we're going to draw lines that would necessarily, or that would reflect into, let's say, the eyes of the person. We're going to say that the eyes of the person, how they would view, or what they would be looking in the mirror with, are going to be at point A. So point A represents kind of like the eyes of a person. Okay, so if I was going to look at point A in a mirror, okay, so the light reflects over into the mirror, so it goes that direction. It would, because it's hitting the mirror perpendicular, reflect straight back, okay, into my eyes. So we would say that it could reflect straight back. And the reflection line, we're going to go ahead and extend into the mirror as a dotted line. So we're going to do something like this. Okay, kind of like that. Now, we're also going to do the same thing with point B, okay, and point C. So in order for point C to hit the eyes, okay, it's going to have to hit the mirror at the very bottom. So it's actually going to look something like this. The light would come up from the feet of the person in this direction, and it would bounce into the eyes like so. Okay, and we would call, and then we would also then, of course, trace the reflective line back into the virtual space, or what we'd be seeing in the mirror. We're going to reflect it back this direction like so. Now, we use point C to reflect into the bottom point here because we want the angle of incidence and the angle of reflection to be the same. And when you have a reflection like this, you need to think about the normal as being this line that comes out perpendicular to the surface. Okay, so in order for this angle to equal this angle, this is where it has to reflect on the mirror. Now, the same is true of point B here. In order for point B to reflect into A, or into the eyes, it's actually going to have to go into the mirror and then up. I'm going to go ahead and color code these so they're a little bit easier to see. Now, that kind of sets up what, all the reflective lines are, and the question is where to place the virtual image. Okay, we know that the virtual image is somewhere out in here. Maybe it's here, maybe it's here, maybe it's here. So we have to decide where that might be. And really, the answer to that is can be found by kind of saying, well, we know that the image distance between the mirror and the real object is going to be reflected into the virtual space as well. So actually, this distance here, and we could call this delta D, or distance to image, is going to be the same into the virtual space as well. Okay, so one way in which we could do this is we can go ahead and take multiple lines from a single point, and we can send them to the mirror. And I'm going to do this in pencil. And the angle with which they hit the mirror will actually be reflected back down. Okay, now that angle will need to be found with a protractor. And if I had a protractor, I could go ahead and kind of duplicate that angle. But instead, what I'm going to do is I'm going to go ahead and fold over the piece of paper. Then I can go ahead and make point C here, kind of pop it through the paper. Draw a line from here to here. and kind of get those same angles that we had. And they're roughly the same. Okay, and what we see is that all of these lines, and if this was perfect, if this was done with a protractor, all the lines would kind of converge in the same spot. And what we're looking for is kind of an image that's somewhere right along here. And so that's kind of where we would consider our image to be. So we're going to go ahead and mark that as kind of where our virtual image would be. And if we measure that virtual image, it should be right around 2 inches. And it is. It's exactly 2 inches in length, which is the same as the image that the object that we started with. Okay, so that's that. Now what would happen, do you suppose, if we were to change the distance between the object and the mirror? And that's what we're going to kind of do. So let's start with, again, a 2-inch object. Like so, and a 1-inch mirror. But this time we're going to place them very close together. Okay, so we have our 2-inch object, A, C, and I'm going to go ahead and place another point at the 1-inch mark. We're going to call that point B. And this time we're going to draw the same lines. If a person is viewing something from point A, we can only view things in straight lines. We consider light to come into our eyes in a straight line. So even though my foot is here, okay, I am viewing, okay, I am going to follow my, what we call line of sight. I'm going to view it in a straight line, and I'm going to view that foot in that straight line somewhere over here. Even though it's a mirror, that's where my brain is interpreting the object to be. And the same thing from if we trace this object back and this object back. And again, if we were to do the handy-dandy math, we would see that this object would end up being about the same space back into the page. So if I were to go ahead and measure the distance between the image and the mirror, we would see that that is approximately 5/8. Okay, and so we're going to mark 5/8, and that is where our image should be. And if I draw a straight line down to here, we should see that what we call A prime, or the virtual A, B prime, and C prime are the same proportions. So the distance between A and B should be about 1 inch, and it is. The distance between B and C is 1 inch, it is, and the total height of the object is 2 inches in the virtual world. So this would be our virtual image. Okay. Now a little bit more clarification on just how do we know where that image is in the virtual world. Let's start with a 2-inch object again. Well, let's make it 3 inches this time. We're going to make it 3. Okay, and I'm going to put a point at 1 and 2 so that we have points A, B, C, and D. And I'm going to make my mirror 1.5 inches here. Now I'm going to pick one point, and I'm going to pick point, I'll probably pick point C, and I'm going to just go ahead and draw kind of lines over to the mirror. Okay, so I'm going to go ahead and draw a line over. I'm going to draw a red line here. I'm going to draw a blue line. I'm going to draw a black line. Okay, so let's just go ahead like so. Now I want to figure out where they're going to reflect. And to do this, I will absolutely need a protractor. Okay, so I'm going to go ahead and I'm going to measure some angles here. And I'm going to try to duplicate those angles. And if we trace all of those lines back, we see that we have a point of convergence right here. And if we measure that point of convergence from the mirror, it is approximately 1.5 inches. And if we look, the original image is exactly 1.5 inches. So the distance here is 1.5 inches, and the distance to this point here is 1.5 inches. And if we were to look at the rest of the image, okay, we call this C prime, we would see that D prime, B prime, and A prime would also end up right on that line. And so let's do it. And there you have it.